Hello students, today's first question is a plus 1 into b minus 1 is equal to 625. A is not equal to b and belongs to positive integers. Then the value of a plus b is. So we have been given that a plus 1 into b minus 1 is equal to 625, and there is a condition that a doesn't belong to b and a doesn't equal to b, and both are positive integers. Right? Now what we need to find what is the value of a plus b. Options are greater than equal to 25, greater than equal to 50, equal to 24, or equal to 26. Now what we will do, we will factorize this. Now this means that a plus 1 into b minus 1 is equal to 1 into 625. This can be written, or I can say 625 into 1. Right? Now in this case, in the first case, so a plus 1 will be equal to 1. So a will be having value 0 and b will be having value equal to b minus 1 equal to 625. So b will be having value 626. So this implies a plus b will be equal to 626. Now in this case we have changed, so that means a plus 1 is equal to 625. So that means a is equal to 624 and b is equal to b minus 1 is equal to 1. So that means b is equal to 2 and a plus b will be equal to 626. 624 plus 2 is 626. Right? Now there is another case, a plus 1 multiplied by b minus 1 is equal to 625. Now I can write this as 5 into 125, or I can write it as 125 into 5. Now in this case a will be equal to a plus 1 equal to 5. So that means a will be equal to 4. B minus 1 is equal to 125. So b will be equal to 126. Now this implies a plus b is equal to 126 plus 4 is 130. Now in this case a plus 1 is equal to 125. So the a will be equal to 124 and b minus 1 is equal to 5. So b is equal to 6. So this implies a plus b is equal to 130. Although by changing it doesn't make any difference, but still we have calculated a plus b for this. Now there is one more product of factors remaining, that is 25 into 25. So this is also equal to 625. So in this case a will be equal to 24 and b will be equal to b minus 125. So b will be equal to 26. So this implies a plus b is equal to 50. Right? Now these are the only product of its factors in which 625 can be represented. So the values of a plus b, you see the minimum value is 50. So we can say option B is the right answer, that a plus b will always be greater than or equal to 50. So right option for this will be option B. If p plus 1 by p is equal to q, so we have been given that p plus 1 by p is equal to q. Now then for p greater than 0, p is greater than 0. Now we have to find which of the following is true. So this is q equal to 0, q is greater than minus 2, less than 2, q is greater than equal to 2, and none of a, b, c. So we need to find basically the value of q. Now since p is greater than 0 and we have not been told that whether p is an integer or non-integer, right? So we'll take different scenarios. Now first of all, since p is greater than 0, let us draw a number line 0, p is greater than this, right? So this is the value of p. This is 1. So first we will assume some value over here, then add 1 and then add greater than 1. Now first is, let us suppose p to be equal to 0.5. Now when p is 0.5, let us find the value of q. So that will be equal to 0.5 plus 1 upon 0.5 equal to q, right? So this equals 0.5 plus this, removing this decimal, so this will be 10 by 5 equal to 2. So the value of q is equal to 2.5, right? Now moving to different case when p is equal to 1. Now in this case 1 plus 1 upon 1 equal to q. So this implies q is equal to 2. Now another case, we can take integer as well as non-integer. So we will take first, let us suppose p is equal to 2. In that case this will be 2 plus 1 by 2 equal to q. Now taking LCM, this will be 4 plus 1, 5 by 2. So this means q is equal to 2.5. Right? Now we'll take some non-integer value greater than 1. So that let us suppose it to be 2.5. So 2.5 plus 1.25. Now see, this is 2.5. So q has to be greater than 2. Right? So we'll calculate this. So this will be 2.5 plus 2 by 5. Right? So q has to be greater than 2.5. Whatever is the value of this. So you see, in all these cases, q is coming out to be greater than or equal to 2. So we can say that q is greater than equal to 2. So option for this particular question, option C is the right answer. If a raised power b is equal to b raised power a, now we have been given a condition that a raised power b is equal to b raised power a, where a is not equal to b and both of these are greater than 1. So that means a comma b is greater than 1. Then the value of a plus b is, so we need to find the value of a plus b. Now we can have different values for a plus b, but there are options 5, 6 and 7. So first we will try to calculate for this. If any one of these doesn't give us a raised power b equal to b raised power a, then we'll say it does not exist. Now first of all we will consider a plus b equal to 5. So that means we can have value for a to be 3 and 2, since a b has to be greater than 1, or I can say 2 and 3, they add up to 5, right? Or I can say 1 and 4, 4 and 1, since it has to be greater than 1, so this is not greater than 1, so we will discard these values. So now a raised to power 3 raised to power 2, so that is a raised to power b, 3 raised to power 2. Does it equal to 2 raised to power 3? So this is 9 and this is 8, so this is not equal. Now I'll check for this. 2 raised to power 3 equal to 3 raised to power 2. This is not equal also. So option A is out of the question. Now moving for option B. Option B says a plus b is equal to 6. Now since these are greater than 0, so I can have only two values, 2, 4, 4, 2. Right? Now 2 raised to power 4 is equal to 4 raised to power 2. So 2 raised to power 4 is 16 and 4 raised to power 2 is 16. So this is equal. So I can say that a plus b is equal to 6. Right? Now checking for 7. A plus b equal to 7. So it can be 3, 4, 5, 2, 2, 5, 4, 3. Right? Now 3 raised to power 4 equal to 4 raised to power 3. Now 3, 3, 9. So this is 81 and this is 64. So this is not equal. Now 5 raised to power 2 equal to 2 raised to power 5. So 5 raised to power 2 is 25 and 2 raised to power 5 is 32. So this is also not equal. Since these two are not equal, so this will be also not equal. So I can say that this option C is also out of question. Option B is correct. So we will say a plus b is equal to 6. Option B is the right option for us. There is a unique 3-digit number which is cube of a natural number. If we shift the position of the digits of this number, the new number also becomes the cube of another number. The original number is. So out of the options, we need to find which number after rearranging becomes the cube of another number. So first is 343. Now 343 is the cube of 7. Right? But if we rearrange it, so it can either become 433. If we arrange it more, so it can become 334. Right? But these are not the cubes of any other number. So we'll discard option A. Now moving to option B, that is 729. Now 729 is cube of 9. Now we'll rearrange the number, so it will become 297, or it can become 279, or it can become 792, right? Or 729. So this is the cube. So all these are not cubes, so we can say option B is also not our answer. Now moving to option C, which is cube of 5. Now if I arrange this into 5, 1, 2, it becomes the cube of 8. Right? So we can say that option C is a cube of two different numbers. So option C is the right answer for this particular question. A relatively very easy question. For n greater than 2, such that n belongs to positive integers, the given expression n raised to power 4 minus n square is divisible by. So we have been given that n is greater than 2 and it is a positive integer. So we need to find n raised to power 4 minus n square is divisible by 4, 8, 12 or all of these. So first of all we will write n raised to power 4 minus n square. Now if I take n square common, I am left with n square minus 1. Now if I put one square over here, so this becomes a square minus b square, which is basically equal to a minus b multiplied by a plus b. So I can write this is equal to n square into n minus 1 into n plus 1. Now The smallest value of n which I can take, being it an integer and greater than 2, is when I put the value of n equal to 3. So I'll check for n equal to 3. So this becomes 3 square 9, 3 minus 1 2, and 3 plus 1 4. Right? Now, is it divisible by 4? Yes, it is divisible by 4. It is divisible by 8. Yes, 4 into 2 8, so it is divisible by 8 also. Is it divisible by 12? For that we have to check by prime factorizing it. So 9 is basically 3.3.2.4. Now 4 into 3 is 12. So we can say that it is divisible by 12 also. So we will mark the option D, that all of these, it is divisible by 4, 8 and 12. So right option will be option number D. At our training institute, we have P minus 1, P minus 2, P minus 3 and P minus 4 processors in the ratio 1 by 6, 1 by 5, 1 by 3 and 1 by 2 respectively. Minimum number of processors in our institute is, so for this is a question of ratio. Now, whenever such like question comes, you need to find the LCM of 6, 5, the denominator. So 6, 5, 3 and 2. So first of all with 2, 3, 5, 3 and 1. Now with 3, 1, 5, 1, 1 and with 1. Right? So this becomes 3, 2, 6, 6 and 6, 5 is 30. Right? So LCM is 30. Now multiplying each ratio with 30. So I will be getting 30 divided by 6 as 5, 30 divided by 5 6, 30 divided by 3 is 10 and 30 divided by 2 is 50. Now we'll add this. So this will become 10 plus 15 plus 10 25, 25 plus 5 30, 30 plus 6 36. So minimum number of processors are 36. So right option for this will be option number D. 392 raised to power n minus 392 raised to power n minus 1 is divisible by. So this is the question, is divisible by 56, 23, 13, 17 is not divisible by. So we need to find which of these is not dividing this expression. So first of all, we will take 392 raised to power n minus 1 common. Right? So here I would be left with 392 and here I would be left with 1. So this expression basically becomes 392 raised to power n minus 1 multiplied by 391. Now whatever be the value of n, 392 has to be there, right? So I can write, I have to need to check for 392 and 391 that whether these numbers divide it or not. Now 392, we will first prime factorize 392. So with 2, 1, 19, 8, 9 and then 6. So this is 196. Now again with 2, 9, 18, 16, 98. Again with 2, so this will be 49 and then 7 and 7. So 392 is basically equal to 2 into 2 into 2 into 7 into 7. Now 391. Prime factorizing 391. Now since 391 is a product of prime factors, so it is 17 into 23. So I will write 17 into 23 as 391. Now 17 option D. So that means this whole expression, since 391 is equal to 17, so option D is out of question. It is divisible by 17, so option D is out of question. 23 option B is also available, so option B is also out of question. Now for 56 and 13. Now 56, you see 2 cube is 8. 8 into 7 is 56. So that means option A is 56 is also dividing this. So only option left is 13. So 13 is not available over here. So we'll say that 13 is not dividing this expression. So right option is option number C. Mr. Chalu, while traveling by ferry Queen, has traveled the distance 1 kilometer more than the fare he paid per kilometer. So that means if he paid, let us suppose rupees X per kilometer, so the distance he traveled is 1 kilometer more, so that will be X plus 1. Initially he had total amount of rupees 350 in his wallet. Now he is only left with minimum sum of rupees 26, 8, 19 can't be determined if all the distance traveled by him is in integers. So let us suppose that fare he paid per kilometer be equal to rupees X. Now the distance he traveled will be distance traveled, since he traveled 1 kilometer more than the fare he paid per kilometer, so the distance will be X plus 1. Now Initially, he had total amount of rupees 350 in his wallet. So some amount have been spent and some has been left. So we can say that x multiplied by x plus 1 is less than or equal to 350. Less than equal to 350. Fine. Now, in the brackets, it has been written that if all the distance traveled by him is in integer, so that means x is an integer, which makes x plus 1 is also an integer. So both are integers, positive integers. Now, we need to find that those consecutive integers which when multiplied give us 350 or some value closest to 350, right? Now, you can easily estimate from here that if I multiply, let us suppose 15 multiplied by 16, so that gives me the value 240, so which is much less than that. So if I try for 18 multiplied by 19, so that is equal to 18 multiplied by 19, so that is equal to 342. Now this value is less than 350, and if I increase it further, so that will be 19 into 20, and this value will go beyond this, which is equal to 380. So this can be the option where x is equal to 18 multiplied by 19 equal to 342. Now with this value he has rupees 8 left. Now we'll see if there is any option. Yes, this is an option B. So we'll say that option B is the right answer. The only hint given to us over here is that these are consecutive integers. So we'll try integers and try to make it equal to or less than 350, and we find the answer. A person starts typing the numbers from 1 to 1999. He presses the key total n number of times, the value of n. So we need to find how many basically digits are there, right? Now, first we will start with 1 to 9, right? So total number of digits equal to 9. Now these are single digit, right? Now we will do for 2-digit number, so that is from 10 to 99. So these are basically 90 digits. So 90 multiplied by 2 equal to 180, that means 2 digits. Now 3 digits starts from 100 to the last 3-digit number will be 999. So total number of digits will be 900. So 900 multiplied by 3, so that is equal to 2700. So these are 3-digit numbers. Now we have to move up to 1999. So 4-digit numbers from 1000 to 1999. So how many are there? So that would be 1000 multiplied by 4. So that is 4000. 4-digit numbers. So these are the total number of keys he had pressed. So now we will add this. So 4000, then 2700, then 180, and then 9. So you see unit digit 9, that is only in one option. So we need to check because there is also an option none of these. So next will be 8, then 8, and then 6. So total number of keys he pressed is 6889. The right option will be option number A. The remainder when 20 raised to power 23 is divided by 17 is. So we need to find remainder when 20 raised to power 23 is divided by 17. Right? Now, if you want, I have made a detailed lecture series on remainder theorem. Now, when I divide 20 by 17, I get the remainder 3. So that means remainder left will be 3 raised to power 23. Since this is greater than 17, so again I have to divide by 17. Right? Now, we know that 3 raised to power 3 cube is equal to 27. So I will write this as 3 cube. So the whole power will be 7. So this is 21. So I will write 3 square divided by 17. Now this is 27. 27 divided by 7 gives me remainder 10. So this will reduce to 10 raised to power 7 into 3 square divided by 17. Right? Now 10 square is equal to 100, and when I divide this by 17, so this is 17 into 5 is 85. So I will change this to 10 square whole power. I can write 3, so I have to write 110 over here, then 3 square is 9, so divided by 17. Now 10 square when 100 divided by 17 gives me a remainder of 15, so I can write this as 15 cube, and here 90. So when I multiply 90, so 17 5 it has, so I will be left with the remainder of 5, and since this is also greater than 17, so again I will divide this. Right? Now 15 raised to power 3 will become quite higher. So I will write 15 square multiplied by 115 multiplied by this. So 15 into 5 is 75 divided by 17. Now 15 square is 225 multiplied by 75 divided by 17. Now 17 multiplied by 13 gives me 221. So when I divide 225 by 17, I will be having remainder 4 multiplied by, when I divide 75 by 17. So in that case, the remainder, you know that 17 multiplied by 4 is 68. 17 multiplied by 4 is 68. So remainder will be 7. So basically 4 into 7 divided by 17, I need to 7 divided by 17 I need to calculate. Now this is 4 into 7 is 28. When I divide 28 by 17, I would be left with the remainder of 11. Right? Because 17 into 1 plus 11. So remainder is 11. So right option for this question will be option number A, 11. Right? Let P be a prime number such that P is greater than 3 and less than 50. So P is a prime number in between 3 and 50. Then P square minus 1 is divisible by. So we need to find whether it is divisible by 8, 12, 8, 24, 12 or all of these. Now P square minus 1 can be written as P minus 1 into P plus 1. Now we will start with the first prime number greater than 3, so that is 5. So putting the value of P equal to 5, I will be getting P minus 1 as 4 and P plus 1 is 6. Now this is equal to 24. Now 24, so it is divisible by 8, it is divisible by 24 itself, and it is divisible by 12. So we can say that option D, all of these is right answer. Now we'll check for some other. So that is P equal to 7. Now P minus 1 will be 6 and P plus 1 will be 8. So this is equal to 48. So now this is again divisible by 24, 8 and 12. So again all of the ABC. So right option for this will be option number D. If P be a prime number, then P square plus 1 cannot have its unit digit equal to. So first of all we will start with prime numbers unit digit. So unit digit of prime number can be unit digit of a prime number can be, first will be 11 and 1, right? Next will be 2, 3, 5, 7 and 9. So these can be the possible unit digit of a prime number. Now since we need to find P square plus 1, so first of all we'll find the unit digit of square of a prime number, So what we'll do for that? So we'll start squaring this. So 1 square will give me unit digit 1, 2 square will give me 4, 3 square will give me 9, 5 square will give me 5, 7 square will give me 9 and 9 square will give me 1. So some are common over here, so I will write that 1, it is 2 times, 4, 5, 9. So you must also write this into your notes that the possible unit digit for square of a prime number will be 1, 4, 5 and 9. Right? Now since we need to find the unit digit for P square plus 1, so we will add plus 1 to each. So that will be 2, then 5, then 6 and 9 plus 1 is 10, so that is 0. So the possible units for P square plus 1 will be 2560. You must write these into your notes because this can help in any question. So the possible unit digits for P square plus 1 are 2560 and we need to find which cannot be its unit digit. So 3 can be? No. So 3 cannot be the unit digit. 9 also cannot be the unit digit. 7 also cannot be the unit because these are not included into this. So we will mark option D that all of these cannot be the unit digit of P square plus 1. So right option is option number D. The number of numbers from 1 to 200 which are divisible by neither 3 nor 7 is. So from 1 to 200 we need to find the numbers which are neither divisible by 3 nor divisible by 7. Right? So first of all we will find the numbers in between 1 to 200 which are divisible by 3. So the very first number which is divisible is 3. Now the largest number below 200 will be not 200, 199, 99, 18, 19, 198. So that will be 198. Right? Now we need to find how many of these are numbers. So nth term 198 is equal to a, that is 3 plus n minus 1 dot 3. So this is 195 divided by 3 equal to n minus 1. So this is equal to n minus 1 is equal to 3, 6, 18 and then 15, 65, right? So n is equal to 66. Now these are the numbers which are divisible by 3. Now we will consider for 7. So first number will be 7 and 199 is not divisible, 190. So if I divide 200 by 7, I will check the remainder. So that will be 7, 2, 14, then 60, 8, 7, 56. So 4 is the remainder. So 196 is divisible by 7. So 196 equal to 7 plus n minus 1 dot 7. So this will be equal to 196 minus 7 divided by 7 equal to n minus 1. So this is 196 minus 7 is 189 divided by 7. So this will be equal to 7 to 14, 49, 27. So n minus 1 is equal to 27 and n is equal to 28. Right? Now we will calculate the numbers which are divisible by 21. Now I will tell you why we are calculating this. So first will be 21. Now I will divide 200 by 21. So I will be getting 21 into 9. So that is 189. So 189. So now 189 equal to 21 plus n minus 1 dot 21. Right? Now 189 minus 21 divided by 21 equal to n minus 1. Now this implies 189 minus 21. So this will be divisible by 8. So n minus 1 is equal to 8 and n is equal to 9. Why I calculated 21 also? See, in the series we have calculated 66 are divisible by 3, 28 are divisible by 7. So that's add up to 66 plus 28, right? So this is equal to 8, 6, 14 and then 6, 2, 8 and 94. Now out of these numbers there will be numbers that will be divisible by both 3 and 7, and which are divisible by both 3 and 7 will be divisible by 21. So we have taken those into consideration 2 times. So I need to cancel this 1 time. So 94 minus 9, that is equal to 85. Now these are the numbers which are divisible by 3 or 7. Now we need to find which are not divisible by 3 nor 7. So for this, total number between 1 to 200 are 200. So 200 minus 85 will give me the number which are not divisible in between 1 to 200 from 3 or 7. So that is 115. So right answer will be 115, or option number A is the right answer. Now let us suppose a number in between 21 and 42. Now when I was calculating numbers divisible by 3, so 21 got included in this also. Why? Because 21 is divisible by 3. But 7 also divides 21. So in this n equal to 28, 21 has also been included. So that means there has been overlapping of some numbers. So that's why I calculated that numbers divisible by 21 have been taken care in 3 as well as 7. So I subtracted those numbers from the totals so as to get only numbers divisible by 3 or 7 one time. So that's why it is 200 minus 85. P is a prime number and p square plus 3 is also a prime number. Find the number of values of p satisfying the given criteria. Now we have been given that p is a prime number. So and p square, p is prime number and p square plus 3 is also a prime number. Right? Now we start with the first prime number, that is 2. Now p square plus 3 will be 4 plus 3 equal to 7, which is also a prime number. So that means there is at least one value which is satisfying this criteria. Now if I take the next prime number p equal to 3, so that will be 3 square 9 plus 3, which is equal to 12, which is not a prime number. Now if I take next prime number p equal to 5, so that will be 25 plus 3 equal to 28. So this is also not a prime number. Now to check for further prime numbers, we will move into some generality. Now after 2 all the prime numbers are odd? No. Odd square, odd multiplied by odd, will always give me an odd number, right? Now when odd number p square is odd, so it is established that p square will be odd. Now p square plus 3, what does that mean? This is also an odd number, so odd plus odd will always give me an even number. We can take some example. 3 plus 5, so this is 8. 11 plus 7, so that is also even. So that means after 2 every prime number when a square is made, so that will be odd, and odd plus odd will give me an even number. So no, there is no even number beyond other than 2, right? So that means this will always p square plus 3 other than value for p equal to 2 will give me an even number. So that will never be a prime number. So I can say that there is only one value of p which is equal to 2 that will satisfy this criteria. So this is basically a logical deduction from this, and for this question the right option will be option number C, right? At a bangle shop, when the shopkeeper tries to display all the bangles in the form of a square, he is left with 38 bangles that cannot be accommodated in the square arrangement. If he wants to increase the size of the square by 1 unit, he need to buy 25 more bangles to complete the square arrangement. However, when he arranges the bangles, he keep all the bangles adjacent to each other without any overlapping. What is the actual number of bangles in his shop? So first of all, we will draw a square. Now, let us suppose he is having in square x number of bangles on one side, right? Now, the total number of bangles he would be having in the first case will be x square. So let us suppose xv, the number of bangles on one side of square box, right? Now, initially he would be having how many bangles? That will be equal to x square plus 38. So that will be x square plus 38. Now, further he says when he increases the size of the square by 1 unit, he needs to buy 25 more bangles to complete the square arrangement. So what does that mean? That means when he increases by 1 unit the size, so that is x plus 1 whole square, he needs to buy 25 more bangles. So that means in equivalent to this, I will subtract 25 from this so as to get this number equivalent, fine. So that basically means x square plus 38 is equal to x plus 1 whole square minus 25. Now, if I open this, so this will be x square plus 38, here it will be a square plus b square plus twice x minus 25. Now x square gets cancelled. So I will be left with 2x shifting minus 25 to this side. So 38 plus 25 is, sorry, this one is also there. So this will be minus 24. So 38 plus 24 is 12, 3 to 5, 62. So x is equal to 31, right? Now, but what is the actual number of bangles in this shop? So that will be equal to x square plus 38. So that will be equal to 31 square, 31 whole square plus 38, right? So that will be equal to 961 plus 38, which is equal to 999, right? So the right option for this will be option number B. Now we'll do some analysis for this question. Now x square plus 38 is equal to 999. Now right side he said that if he increases it by 1 unit, so that means this will become 32. So 32 into 32 is equal to 1024. Now he had said that he needed to buy 24 bangles. So when we equated this, I put a negative sign. Why I put? Because this has now increased. So I need to subtract minus 25. So when I subtract 25, so it will become 999, and that's why I put the equality sign. You might be confused why I subtracted 25, because as I increased 1 unit, so the value of x will make it far more greater than this. So I need to subtract 25 because 32 is 1024. 32 square is 1024. I subtracted 25 so that the equality sign can be placed inside, right? Or there can be another approach for this. Now, since we need to find what is the actual number of bangles in this shop, so I will write the 3 options 1690. So this is the general approach. Next is 999 and next is 538, right? Now if I subtract 38 from it, 38 from all of this, so I will write first 1690 minus 38, so this comes out to be 1652. Next is when I subtract 999 from 38, so that will be 961, and 538 minus 38, so that will be 500. Now out of this, when I subtract 38, the answer should become a perfect square, as this is the side of a square. So neither this nor 500 is a perfect square, so the right option will be option number B. So you can also approach, but if there is one more variable introduced, let us suppose another which after subtracting 38 gives me a perfect square, then you have to go through this way or satisfy the whole condition, right? So you can start with any of the methods. if a and b are two integers which are multiples of 5, which of the following is not necessarily true? So first is a equal to, let us suppose some values for this that satisfying the condition that it must be multiple of 5. So let us suppose a to be 20 and b equal to 15. Now, which of the following statement is not necessarily true means that they need not to be true. In some cases it can be true. So first is a minus b is divisible by 5. So whenever there will be subtraction, so there will be 1 5. So this has to be true, that it is divisible by 5. A minus b is 5. Now moving to second, a plus b. So a plus b is 35, is divisible by 10. So this is not divisible by 10. So you can say statement B is necessarily not true. So for the sake of question, we'll move to statement C. A square minus b square is divisible by 5. So a square minus b square is basically a plus b is 20 plus 15. So a square minus b square will be equal to a plus b into a minus b. So that is equal to, since we have calculated that a minus b is divisible by 5, so a plus b is 35 and this is 5. So it is also divisible by 5. Fine. So this is true. No. Statement D tells none of the above. So there is one statement or statement B which need not to be necessarily true. So we will say that option B is correct option. But if I suppose the value of A to be 10 and the value of B to be 10, then in this case this is also true. So need not necessarily true means that both the cases are possible, may or may not be. So statement B is the right option. Thank you for today's lecture. Bye bye. Take care.